Hi guys, Audrey here. So today we are going to develop a formula for something called integration by parts. So we have learned how substitution works and how when we're doing substitution, we are sort of undoing the chain rule. Some other differentiation rules that we learned are the product rule and the quotient rule. So integration by parts is actually going to show us how to undo the product rule. Undoing the product rule. So the first things that we need to remember here then are that we know that the integral of f over g dx does not equal to the integral of f dx over to the integral of g dx. And we know that the integral of f times g dx does not equal to the integral of f dx times the integral of g dx. So in other words, we know that we can't distribute the integral into a quotient or a product. So integration by parts in undoing the product rule is going to give us a way to sort of think about this. So if we want to undo the product rule, the first thing that we really need to do is remember the product rule. So the product rule. Tells me that the integral of f, that f times g, the derivative of f times g is equal to the derivative of the first times the second plus the first times the derivative of the second. So what we're going to do to undo the product rule is we're sort of just going to manipulate this formula a little bit. And it's going to be really important to remember one of the fundamental theorems of calculus, which is that an integral is answering the question, what is this function the derivative of? So if I were to look for the integral of f prime dx, then what that's doing is saying, what is f prime the derivative of? Well, f prime is clearly the derivative of f. So this would just be f and then plus or minus some constant. So what we're going to do over here to the product rule, we're going to use this fundamental theorem and we're going to take the integral of both sides. So that I am looking at the integral of fg, oops, I'll do that in blue, the integral of fg prime is equal to the integral of f prime g, and we are, remember, allowed to distribute integrals inside of an addition, so I'm going to do that, plus the integral of fg prime. And now that fundamental theorem that we just learned, or that we just remembered rather, tells me that this integral of fg prime, well, what is fg prime the derivative of? It's just fg, that I can get rid of that. So fg is equal to the integral of f prime g plus the integral of fg prime. So here we distributed the integral into the addition and applied the theorem. So then the next thing that I'm going to do is I'm going to actually solve for this one right here, for fg prime, by subtracting that other integral to the other side. So here I have the integral of fg prime is equal to fg minus the integral of f prime g. So here we solved for that integral. And now the last thing I'm going to do is I'm actually going to change the names of these functions. Instead of using f, I'm going to use u. And instead of using g, I'm going to use v. So I'm going to say that f is equal to u and g is equal to v, so that I can just change the names, because typically we think of this formula in terms of u and v. Now, when we look at this formula, inside of it, we have a g prime and we have an f prime. So when we're taking the derivatives, we're going to think about it how we were thinking about it more with substitution. So f prime is du and g prime is dv. So then I'm going to rewrite this formula in terms of that u and v. So this would give me u dv is equal to uv minus the integral of v du. And this right here is actually our integration by parts formula. And what it's doing is it's kind of like separating the product rule, and it's saying if we look at an integral and we can think of it as, hey, look, this part's a function, this part's the derivative of some function, then we can rewrite that integral in terms of some function minus some new integral, with the hope that that new integral is actually easier to calculate. So we're just going to do one really quick example of a really easy thing to see how this formula works. And then in class, we'll actually go through and really like get deeper into the formula. But this is the formula that we will be using for integration by parts. So the first thing that we will do here is the integral of x times e to the x dx. Now, what we're doing, we're trying to look at part of this and say, hey, we want to think of this as a function. We want to think of this as the derivative of something. So we will learn good ways for doing that. Right now, I'm just going to tell you that here my u, we're going to pick it to be x, and my dv, we're going to pick it to be the rest of it, e to the x dx. So in other words, I've used every single thing in my integrand. If I multiply u times dv, I get everything in the integrand there. So u dv should make up the whole integrand. Okay, so then if I want to apply the formula, what else do I need in the formula? I need my du. So my du, that's the derivative of u. The derivative of x is just 1. So we're going to have 1 dx there. And then, so here I took the derivative. Then I have dv, but in my formula, I need a v. So to get v from dv, again, we're just kind of using that fundamental theorem that we had right here. We just take the integral. So here I am integrating. And when I integrate dv, I get v, and we know that the integral of e to the x is just e to the x. So we don't need to do a plus c here. That'll just kind of get in the way and make things more complicated. So then when we apply our formula, we can see that we are doing u times v. So we kind of have that arrow going down, x times e to the x minus the integral of v times du. So in other words, if we stick this directly into the formula, we get the integral of x e to the x dx is equal to u times v minus the integral of v du, which was 1 dx. And notice we did end up here with a simpler integral. So then not only is it a simpler integral, it's a known form. We know the integral of e to the x is e to the x. We actually just did that. So this is x e to the x minus e to the x plus a constant, and that is my final answer. So we have come up with a formula that undoes the product rule, and we've seen how we can use it when we are given an integral of a product right there. We will answer all of the questions that you have about this in class. All right, bye guys.